Hi everyone, welcome back to the channel. In this series, we are going over Leetcode problems, and today we are looking at Leetcode 167, TwoSum 2, the input array is sorted. So similarly to TwoSum 1, we are given an integer array, we are given a target, and we need to return the two indexes of the values that add up to our target number. But in this instance, our input array is sorted. The problem states, given a one-indexed array of integers numbers that is already sorted in non-decreasing order, so ascending order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers of index 1 and numbers of index 2, where 1 is less than or equal to index 1, which is less than index 2, which is less than or equal to the length of our numbers array. Return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array, index 1, index 2 of length 2. So not just the indexes, but our indexes plus 1. The tests are generated such that there is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. So if we look at the example 1, values 2 and 7, the first two values equal our target number, and instead of returning 0 and 1, we are returning 1 and 2 because we need to add by 1 to our indexes. So in this approach, what we're going to do is use the two pointer, and we're going to have one pointer set to the beginning, one pointer set to the end, and we're going to compare the values, the sum of those values compared to our target number. Is it equal to, is it less than, is it greater than, and determining which of those is true. So if we reach our target, we're going to return the target output. If our values are less than our target, we want to move our pointers to the right, or at least move one of the pointers to the right to increase. And if we want to decrease, if our target number is less than what we have as the sum of our values, we'll want to move our pointers to the left. So to get started on that, we're going to initialize our start pointers, our start pointer, our end pointer. Sorry, that's actually going to be the length of our array minus 1. And in this instance, because we can't use the same value twice, we know that our pointers cannot overlap each other, because then in that instance, they are either the same or they have already seen those values before. So as soon as our pointers meet, so while start is less than end, then we want to go on with our logic. Otherwise, there is no indexes whose value equals our target. So while we're in our while loop, that's where we'll put the logic. Other than that, we want to return an empty integer array. Okay, so while we're in our while loop, we're going to want to keep track of, now that we have the two indexes, we'll want the values. So we'll say num1 is equal to our index of numbers at the start location, and int, so num2 is equal to numbers at our end position. And then once we have that, we'll want to add these two. So another way you can do it, we just call it total, is equal to num1. And you could probably have done this all on one line, but just to break it down easierly, you can see what is happening. Our total is num1 plus num2. So now that we have the total, we'll want to check, does our total equal our target number? And if it does equal our target number, we'll want to return a new integer array. And in our integer array. We are going to do num1. Sorry, actually, because of this, we are not returning the values, we're returning the index. So we are going to do our start pointer plus 1. Don't forget that was one of the constraints is added by 1. And that's going to be our first item, and the second item is going to be end pointer plus 1. I need to change these parenthesis types. Okay. Else, we want to know if our total is greater than our target. We want to take our right pointer and move it downwards because we're too high. And that'll decrease our end pointer. Otherwise, that must mean that our target is less than, or our total is less than our target, and we'll want to increase our start pointer. And that will continue on, like we talked about before. It'll continue on until the start is either at end or they are overlapping, and that means that we haven't seen any values that equal our target. We'll go ahead and run that. Forgot the else if. There we go. And our test cases pass on this. This was an interesting one. I kind of liked this one better than TwoSum 1. Knowing the two-pointer approach is very helpful in this and keeping our time and space complexity optimized. If you have any questions, feel free to comment below. Otherwise, thank you so much for watching, and I will see you in the next video.